This is the gravimetric analysis of a carbonate lab. Essentially, this is a precipitation analysis lab. The main objective of this lab is to determine the group 1 carbonate, or the identity of the group 1 metal carbonate. So students are given the idea that I have either lithium carbonate, sodium carbonate, or potassium carbonate in the two reaction containers labeled A or B. And so students are given either A or B, and they are to determine if they have lithium carbonate, sodium carbonate, or potassium carbonate. And again, we're using gravimetric analysis or precipitation analysis to determine the outcome. So let's begin. First step is to measure out my carbonates. And in this virtual lab, I'll be giving you the opportunity to pick either A or B to determine what the chemical formula is of the group 1 metal carbonate. So let's begin with A. So what I'm going to do here is tear out my weighing boat so that the scale thinks that the weighing boat is part of the scale. And now I'm going to add A. I'm going to use the scupula to measure out a value of A that is approximately 1.5 grams. I want to stay under 1.5 grams because I know the excess amount of the solution I'm going to add to precipitate this out. So the value is 1.36 grams of A. I'm going to add that into my beaker labeled A. And again, I'm providing two samples for two different students. I'm going to do the same thing now for sample B. And I'm going to hit re-0 again to tear out that weight. And I'm going to take sample B using a clean scupula. And again, I'm going to stay within 1.5 grams. That was too close to the other measurement, so I just want to be a little bit different. Okay. And that's the mass of sample B. And I'm going to pour that, or put that entirely into B. Okay. Now there may be some remnants. No, that looks pretty dry. Okay, those are anhydrous salts, by the way. Okay. Now while I'm at it, I'm going to hit 0 again, and I'm going to mass out my filter paper that I'm going to be using later to collect the precipitate. So we will start. So I'm going to mass out the filter paper. That is going to be what I'll be using to separate the solid, the precipitate. And so 0.40 we can use. And that's for A. And for B, 0.39, very, very similar as we would expect. Okay, so the next step is that we're going to add water to dissolve these group 1 carbonate. And now we're going to add distilled water to both of these group 1 carbonates. And because they are group 1 carbonates, and knowing our solubility rules, they will dissolve. The amount of water I'm adding is not important, since this lab is all about obtaining the moles of the precipitate that will give us insight of the moles of this compound that we started with. So the amount of water is clearly not important here. The idea is that we're going to dissolve all the moles of the carbonate ions. The carbonate ions are what we're after. Okay, so we're going to stir. And we're going to use our stirring rods. And I'm just going to stir and our solid will disappear, or dissolve, I should say. It's not going to disappear. It's important to dissolve all of those carbonate ions, because those carbonate ions are what we're after. And again, the amount of water is inconsequential here, because we have all the salt dissolve. We have the mass of the salt, and all of the salt, particularly those carbonate ions at -2 ion, is what we're after here in this precipitation analysis. Okay, and then we're going to do the same for B, and it's almost dissolved, and we're going to use a different stirring rod here. And it's all dissolved as we would suspect. Group 1 ions are always soluble. They have a low charge, so therefore they coulomically attract the carbonate weakly, so therefore water can compete for those charges and dissolve them. Okay, and so now we have the dissolved carbonates from the two different group 1 metal carbonates that we're trying to identify out of the 3. And now we're going to add a chemical that's going to deliver the calcium +2 ion. So I am using calcium chloride solution. Okay, and this solution is a 0.2 molar solution. And I'm using 125 milliliters, at least 125 milliliters, because I want to add excess. All right, and when I add the calcium chloride, we should know that we're really delivering calcium +2 ions and chloride ions. And we know chloride ions or halide ions, like chloride ions, are soluble. There are some exceptions you should be aware of, but those exceptions do not exist in this beaker. So it's really the calcium +2 that's going to find the carbonate +2, and those have 2 high positive charges, and those are going to make a precipitate. And so as I add the calcium chloride, and I'm adding excess amount of the 0.2 molar, we should see a precipitate form. And there it is. Again, I'm adding excess, so I had to at least add 125 milliliters here. Okay, and I do the same for the other salt or other solution for A. And there's our precipitate. Notice we can't see through the solution because now it's a heterogeneous mixture of ions and, in this case, salt, okay, or crystals that are suspended. This is now a colloid. So let's stir just to make sure that all of the carbonate ions, and this is B, all the carbonate ions get in contact with the calcium ions. Using a different stirring rod, I'm going to do the same thing here for A. Okay. So at this point, what we're going to do now is we're going to filter out our precipitate and dry it, because the whole point of the lab is to obtain the mass of the precipitate and thus the moles of the precipitate, a how many number, and knowing the moles of the precipitate and knowing its calcium carbonate, I can work backwards to figure out the moles of my initial group 1 carbonate, and that's the key. Once I have the moles of the carbonate with the grams, I can come up with a formula mass. Very good. So let's continue. So we're going to separate the precipitate using vacuum filtration. Particularly, we're going to use a Buchner funnel. And we've got an aspirator set up here. So this is a water spigot. And essentially by turning the water on, I'm running water straight through this little tube here. And what's happening is, by the Bernoulli's principle, we're lowering the pressure. By making the water go in this direction downward, it's organizing the air and making the air push outward less but essentially I'm creating a low pressure scenario in the tube and in the flask, and the high pressure is pushing down. I take my A filter paper and I'm going to place it into the Buchner funnel. It's made to fit in there. I'm going to take my wash bottle and I'm going to just wet it. This is made of course, distilled water, so there's no ions in here. I'm not going to change anything in the experiment because essentially it's the amount of ions in solution, not the volume. And I'm wetting it because I want the filter paper to sit against the Buchner funnel. And of course, the running of the water creates a low pressure scenario, and that's going to draw our solution through and capture our precipitate. So I'm going to take A, and I'm going to slowly pour that through. You take my rubber policeman and guide any solid precipitates that I see here. Okay, so I'm just going to slowly pour, and we're going to capture our precipitates. Now, the problem with catching or separating our precipitates is that it's almost an impossibility to get all precipitates. We'll do our best here, and if we have to filter a couple of times, we will. Okay. And if I look at the filtrate below, it's not absolutely clear, so I will run this once or two more times. Understanding I won't get all of them. I will try to get all the precipitates. Again, it's really good to try to push the solids with the water or the rest of the solution. I know I have calcium chloride, and of course you should recognize the fact that I've got either potassium, lithium, or sodium ions and chloride ions that are spectating here. And since it's vacuum filtration, just make sure that it's seated nice and tightly. I know I didn't quite do that beforehand, but all right. And it's pulling through, and as you can see, I still have some solids here. So I'm going to, a couple of things I could do. Well, one thing I'll do is take my wash bottle, again made of distilled water with no ions, and I'll wash this side up, give it some more fluid to get all of these solids out. Remember, this is my data. This is precipitates. We're going to use the calcium carbonate, essentially chalk, right? Precipitate, that's the part of the lab that I need. I need to know how many moles of precipitate. So again, I'm just going to pour and observe that I still have some solids in there. Not a lot. And again, I'm going to try to do our best to get all that we can, understanding that there is a limitation to get all those precipitates, but we're going to try our best to get them. Looks pretty clean, and I'll do that one more time. Okay, now looking at my filtrate, it's just a little bit cloudy, so what I'm going to do is stop the water. Okay. Gently take the top off. You can hear the difference in pressure when I remove this. Okay, maybe not too great. And there are some solids there. You can see there was some lines or some dots that you could see where the filter paper was running through. So gently put that here. Let that stand up. And what I'm going to do is essentially unhook this from the pole stand, and I'm going to pour this through back into the beaker, and we'll filter one more time. Buchner funnel back on, and then I'm going to tighten this clamp up so that I have some good support for my vacuum filtration system. Okay, and you can see that it is a bit cloudy, and we'll try this one more time. Certainly clearer than it was the first time, and slowly pour. Hard to see any real solids here. My filtrate looks a bit clearer. Yeah, and that's about as good as I'm going to get. Okay, understanding that I probably did leave behind some small traces of calcium carbonate. So my next step is I'm going to take my watch glass, okay, and I'm going to get this filter paper out. I'm going to conserve some water here, and I'm going to take what we call a spatula, and we're going to remove the filter paper, kind of like removing an omelet here. So carefully take this off, and all I'm going to do is kind of scrape around the edge to get a corner up and try to get underneath it, and try not to lose any of my precipitates. We have the mass of the filter paper. All we need now is to dry this. I'll put that in an oven. I'll keep this to the side, and we'll put them both in together when we're ready. All right, and now we're going to do this again for solution B. So we're going to grab the filter paper for solution B. We have that masked out, dried already. I'm going to put that into the Buchner funnel, and we're going to make sure that my Buchner funnel apparatus here is tight. My vacuum filtration has got a good seal. Turn on the water, create the low pressure situation inside the conical flask. Wet my filter paper so that it seats tightly onto the filter. And here we go, grabbing the precipitates in for salt B. And now we're going to put into the oven and dry. So after about 45 minutes, I'm going to remove our samples of dried calcium carbonate from the oven. There's our A. And carefully keep the chalk. And there's B. And now we're going to mask them out for a final massing. So we're going to take sample A. It is now dried filter paper and dried calcium carbonate. We're going to carefully try to remove that onto the scale. We have re-zeroed it. 1.58 is our mass of our filter paper and our calcium carbonate. Subtracting out the filter paper earlier, you should have the mass of your calcium carbonate for sample A. And that, of course, is important in order to know the moles of calcium carbonate. And working backwards, we get the moles of the carbonate ions in solution that came from the metal 1 carbonate. Here comes sample B. And that's 1.16 grams of the calcium carbonate dried in filter paper. Of course, subtract out the filter paper for B, and you will have, of course, your value of your dried calcium carbonate. And just for fun, since we already have those values, you can see the chalk that we created here. The calcium carbonate, major solid form of the carbon cycle on the Earth. Okay? All right. Hope that helped.